Screen is visible to everyone? Yeah. So I think we can start. Okay. So good evening to everyone. Myself Swapnil Balasaheb Godke and currently working as a doctoral research scholar at the Indian Institute of Technology Roorkee and also working as a teaching assistant for the development and applications of special concrete with Professor Sudhir Mishra sir. So this session is regarding to the weeks 7. I hope you have no doubts in previous sessions and you all have gone through all the assignments. I think someone has unmuted. Can you mute it, please? Yeah. So first of all, we'll see the recap of week 7. Briefly, we'll see what are the content of the week 7. Then we'll see some of the questions of previous assignments, and you'll get some idea how to solve the questions for the week 7. So the week 7 is totally divided into three parts. The first one is the batching and mixing of the concrete procedure. Second one is the shotcrete concreting, and third one is the high strength concreting. So we'll see step by step. The first of all, we'll go with the batching of concrete. So batching is the process of measuring concrete ingredients by mass or volume, and particularly we'll mix with them. So batching means particularly we'll weigh the material with the help of the in kg or in grams like that in mass way, and in the volume we'll measure in the meter cube or in the liter. So in the case of accurate measurement, it is required to ensure uniform concrete quality. To have the uniform concrete quality in the two mixes, there should not be any difference between the measuring process. For like some tolerance is acceptable, the tolerance will see how much it is acceptable, particularly with respect to each ingredients of the concrete. So most standards recommended batching by mass. Earlier it was the volume batching is recommended, but now it's to have the more accuracy, the mass batching is recommended. So such as ASTM C94, ASTO M157, even Indian Standard Code also recommends the mass batching or weight batching. So, and water and liquid admixtures may be measured by mass or volume. In both the way we can measure and we can incorporate into the concrete mixing. So, volumetric batching generally recommended by ASTM C685, and it is generally used for the continuous mixers. So what is the continuous mixers? We will see into the coming slides. Types of mixers and that all things. So batching of concrete accuracy requirements. Because why accuracy requirements? If you want to go for the mixing procedure in the multiple batches and you want to produce the same concrete with the same constituents, like it's fresh properties and hardened properties. So appropriate or accurate batching is very required. and we have to follow same mixing protocol also to have the same properties of the concrete, both fresh and hardened. So cementitious material plus or minus 1% tolerance is acceptable. Aggregate plus or minus 2% is acceptable. Water 1 plus or minus 1%. Admixtures plus or minus 3%. Means suppose you are doing concreting for one batch of the mix and you calculated 10 kg of the cement, suppose. For example, it's very small amount, but it's just we are supposing one example. So 10 kg of the cement, and in another same concrete you want to produce, another batching you consider 10.2 kg. It is not at all acceptable because it is more than plus or minus 1%. So that's why we have to be take care of all the constituents within the limit of the tolerances. So equipment should measure materials within these tolerances for every batch. Scales and batching equipment must be checked periodically and adjusted when necessary. Means why we have to adjust it and clean necessarily, because what happens if you are using the same mixer for every time. Usually we'll use the same mixer for every time. If we are not cleaning properly, earlier mixed concrete will get hardened and it will stick to the inside the mixer or in mixer's blade. So when you are going for the next concreting, there is a possibility that earlier concrete will affect the efficiency of the mixing procedure, which will not provide the homogeneous mix, as well as there is a possibility to absorb some amount of the water or moisture from the new concrete by that earlier stick concrete or hardened concrete. So that's why we have to be take care this point. We have to clean after the batching. We have to clean the mixer after every batching if it is possible. And if you are going for the continuous batching, we have to be take care there is a no stick of the material or no sticking of the material inside the concrete mixer. In case of the admixtures addition, generally we will use chemical admixtures such as the in previous lectures we saw that water reducing agents admixtures, that is superplasticizers. Then we saw viscosity modifying agents. So sometimes viscosity modifying agents will be in the powder form, but if any admixture it is in liquid form or aqueous solution, it can be measured by volume or mass batching, any type of batching, because both are almost similar in the case of the liquid. So admixtures not added in solution may be batched by mass or volume as recommended by the manufacturer. Every admixtures, their recommendation, use of recommendation is given on the their packet. Suppose you are using the PCB based super plasticizer, the admixture producer has given some recommendation, the particularly the use, how to use, whether it is volume batching or mass batching or percentage, how much percentage you can incorporate into your concrete mix. It may be vary according to your material constituents, but some of the general idea they have given because they have tested into their R&D laboratory, and then they have given these recommendations. So admixtures not added in solution may be batched by mass or volume as recommended by the manufacturer. Admixtures dispensers must be checked frequently to avoid errors that may affect fresh and hardened properties. The measuring equipment of the admixtures we have to be check properly whether they are providing the perfect measurement, or some if here they are not providing perfect measurement you can change. So this care you have to be take or to keep within your concrete batching. This plot indicates dry mixing, wet mixing, and discharge period. Particularly when dry mixing and wet mixing, this period is called as loading period. Means first of all we'll go for the dry ingredients mixing to get the homogeneous mixing procedure. Then we'll add some amount of water or super plasticizer to get the wet mixing. So these all procedure included into the loading period. Then we'll go for the certain amount of time for the mixing to get the homogeneous concrete. That is called the mixing period. And discharge period is particularly not indicating the any time here, but it can be vary according to the type of material or type of concreting you are doing or producing, or type of mixer you are using. Short mixing or long mixing, that is depend on the your requirement. So what are the types of mixers are available? Particularly two types, batch mixers and continuous mixers. In the batch mixers, we'll have drum mixers, then we'll have pan mixers. In drum mixers, we'll have non-tilting, reversing, and tilting mixers. We'll see the images of the type of the mixers, then you'll get the more idea how they will work and how it will be look. So first we'll see batch mixer. So batch mixer, the name itself indicates batch means we are producing concrete into the batch by batch, one batch at a time. That's certain. Obviously, we are producing into the batch of time, so there is a possibility to have the small mixers. In day-to-day life, also we saw on the construction sites, particularly small construction sites, as well as in the lab. Also, we have the batch mixers. We'll produce certain amount of concrete or mix into that one, and then we'll discharge it, and then we'll produce another batch of concrete. So that type of mixers called batch mixers. So after each mixing, there is a necessary to empty completely and clean it properly to don't have adverse effects on the fresh properties and hardened properties of the concrete. So basically, two types of rotations will be in the batch mixers: horizontal or incline, that is called drum mixers, and vertical, that is called pan mixers. So I hope you have seen both the types of mixers. Drum mixers is common, pan mixers are not that much common and available on the construction sites. So drum mixers consist of rotating drum with fixed blades. Drum mixers are generally which are having the rotating drum. Drum will rotate, outer drum will rotate wherever we'll put the concrete, and the blades will be the fixed into that drum, and all together rotating around its central axis. Then pan mixers may have either blades will be fixed or either blades will be rotate. That is depend on the arrangement of the particular type of pan mixers. Next, blades are attached inside the movable drum. The main purpose of the blades is to lift the material as the drum rotates. And during each rotation, the lifted material falls back to the bottom of the drum and the mixing cycle repeats. So, why blades are required? To get the homogeneous mix. How they are creating the homogeneous mix? When the drum is rotating, they will lift the material from the bottom to the top, and then they will drop to the bottom again. So that dropping and lifting mechanism will create to mix or homogeneous mix, allowing the mix will get properly occur. This is the schematic diagram of the or cross section of the drum mixer. You'll see this is the central portion perpendicular to the screen. That is the tilting axis along which we are rotating it, and this is the axis of rotation where that blades will rotate it. So this is the entry and this is the exit of the concrete material. But which type of material? Input of materials for all the drum mixers. Exit of concrete for tilting and reversing drum. Means tilting and reversing drum mixers will have the same entry and exit point for the concrete. But in the case of the non-tilting drum, so where drum is not possible to rotate around the axis, in that case entry of the concrete material is one and other is the axis in this axis direction, that is exit of the concrete. So what parameters we have to be consider or we have to be keep in mind while considering the mixing procedure? One is that rotation speed of the drum, then angle of inclination of the rotation axis. So can anyone tell me what happens if you are rotating drum mixers very fast and slow? Two different aspects. One is the faster mixing and another is the slower mixing. What will happen? Anyone has any idea? Yeah, depend on the water cement ratio. If we have the flowable concrete, if we are producing very fast or rotating very fast, there is a possibility to have a segregation. Okay, and angle of inclination. Yeah, means what happen? Yeah, yeah. Yeah. What happens? Like we have this horizontal axis. Axis is our base axis, and we are rotating with respect to that horizontal axis. Hmm? That is angle of inclination. Suppose horizontally, we'll have that is what we call zero degree inclination. So in the case of 0 degree inclination, you just imagine the drum is mixing in the 0 degree inclination. There is a possibility, there is a chance to have the highest amount of mixing energy required because that mixer has to carry whole the concrete or all the concrete together to lift up and then drop it. So it requires higher amount of mixing energy. But when you consider this opening is at the top, that is vertically, this axis is vertical, this like this. So there is no possibility to or zero amount of energy or very least amount of energy required to mix in the concrete, but there is a possibility there will be no homogeneous mixing of the concrete. So that's why we cannot go with the 0 degree and we cannot go with the 90 degree also. So we'll go the recommended value is 15-degree inclination. 1 5. That 15-degree inclination provides the minimum or optimum amount of energy for the mixing purposes and gives the homogeneous mixing, particularly in the case of the tilting drums or reversing drum. So three main types of drum mixers. One is non-tilting drum. We saw we have the like entry point and exit points are different for the non-tilting drums. Tilting drums and reversing drum, we have both entry and exit point for the concrete are same. So first of all, we'll see non-tilting drum. So in the case of non-tilting drum mixer, you'll see this schematic. Here we are giving the input of the materials. The mixing will happen here. This is the closing point or some sliding will be there, which is closed these exit points. When you want to discharge the material, we'll move it this one and we'll get the material exit from these points. So two different points in the case of the non-tilting drums, the orientation of the drum remains fixed. Only blades will be mix the material inside the non-tilting drums. Materials are added at one end and discharged at the other end. Reversing drum. Reversing drum means we have the both the entry and exit are same. So similar to non-tilting mixer, but the same opening is used for both charging and discharging concrete. The drum rotates in one direction for mixing and the opposite direction for the discharging of the concrete. That's why it is called as reversing drum. Suppose it is mixing in clockwise direction, it will rotate in an anti-clockwise direction in the case of the discharging of the concrete purposes. This is a very important sentence because the name itself suggests reversing. Reversing means reversing in the direction. And two types of blades are attached in the inner walls of the drum. One set of blades lifts the concrete upward and towards the center when the drum rotates in one direction, while the second set of pushes the concrete toward the opening when the drum rotates in the opposite direction. So the two blades have the different type of purposes. So according to their arrangement inside the mixer will be also different. One will work efficiently into the mixing direction. Suppose we are considering the clockwise and anti-clockwise, other will have the 100% efficiency, which will push the concrete toward the opening of the mixer. Okay. The blades are arranged in a spiral pattern to achieve effective mixing and discharge. That's why I said the arrangement will be the special. That is, spiral pattern will be arranged. The blade will be arranged in a spiral pattern inside the mixer. That reversing drum mixers. So reversing drum mixers are commonly used for batches up to 1 meter cube. So when you are going for the concreting up to the 1 meter cube, the reversing drums are efficient. But if you are going beyond that one, it will be not efficient. In that case, you have to use the other type of the mixers. So what are the other types of mixers? We'll see. Another is tilting drum. Tilting drum means it is not about the rotating in different directions or opposite direction. It rotates in the same direction. Just you have to tilt in a such a way that the concrete from the mixer will get discharged out of the mixer. So inclination of the drum can be varied. When the drum is almost horizontal, just now we discussed that one, inclination, more energy is provided because more concrete is lifted for the full diameter of the drum before dropping. Horizontal means 0 degree inclination along the horizontal axis. And that's why we require the more energy to lift all the concrete to up and then again drop to the center. Mixing occurs during the dropping of the concrete, therefore higher drop results in a greater mixing energy. If the axis of rotation is almost vertical, that is 90 degree to the horizontal, vertical, The blades cannot lift the concrete effectively and mixing becomes poor. So that's why code has recommended based on the various experiments and the value has been recommended 15 degree. The drum axis usually kept at about 15 degree from the horizontal. Then only we will optimize the mixing energy, will provide the more homogeneous concrete compared to the horizontal and vertical direction. So how tilting drum looks like? This is the tilting drum. We saw opening and exit are same. Here, this is the axis of drum rotation, and this is the center perpendicular to the screen. That is tilting axis. Okay. So here you will see we while filling the mix or ingredients of the concrete, we'll keep it up, and then while the rotation, we'll keep it into the 15 degree while the mixing is going on. In the case of the discharging, again we have to go down and the material will come out of that one automatically while mixing itself. So there is no need in the case of the tilting drum to go in rotation into the opposite direction. But in the case of the reversing drum, that procedure is there or that mechanism is there which will go into the opposite direction. So in the case of the tilting drum, if the axis of rotation is almost vertical, we saw that blades cannot lift the concrete effectively and mixing becomes poor. So 15 degree is recommended. Now this all about the tilting drum and non-tilting drum and reversing drum. But what about pan mixers? In the case of the pan mixers, this is like a cylindrical type of arrangement will be there. That cylinder where we'll put all the concrete ingredients. A cylindrical pan, fixed or rotating. Pan may be fixed. In this case, the pan is fixed, and in this case, pan is rotating. While one or two sets of blade rotate inside to mix the materials and blade scraps the pan wall. Means here one type of blade is available. That is plus sign you are seeing. That is one type of blade available. In sometimes subtypes of the pan mixer, you will observe two types of the blades, different types of the blades for the more rigorous mixing required. Here this is the scraper. Here pan is fixed, but this blade is rotating. Along with that, this shaft is or scrap is also rotating. What we'll see what is the purpose of the scrap. In this case, the pan is rotating and scraper is fixed. The scraper is fixed, pan is rotating, and the blade is rotating. So, can anyone tell me what is the use of this scraper? Why that is provided in the pan mixer and why it is not provided into the other type of mixers? Yeah, for lifting, or we can say, uh, yeah, right. You can say that the material should not get stick into the surface, and that scraper will allowing that material to push towards the center, that is towards the blade. So that's why scrappers are provided inside the pan mixers, because we are not giving any inclination into the pan mixers. So that's why there is no extra energy, mixing energy we are providing to lift the material. So that's why this scraper is required to push the material towards the blade, or not allowing the material to stick to the surface of the pan. The shape of the blades and axis rotation may vary. That is the different part of the discussion. Another important element of the mixer is scraper. Here we saw sometimes the axis of rotation of the blades coincides with the pan axis. This axis of the rotation and the pan axis sometimes coincide or rotate in the same RPM or same speed, but sometimes it will be differ. In which case, see offset axis. Some pan mixers have an offset axis. Offset axis means the blades will not be exactly at the center. In this mixers, two rotations occurs. Two rotations means either in this case counter current motion and planetary motion. So in the counter current motion, pan rotating, scraper fix. Here pan is rotating, scraper fix. The shaft is also rotating following arrow 2. This one is also rotating following arrow 2. In this case, planetary motion. Pan is fixed, scraper is rotating, and this is also rotating. So this blades, pan, and scraper all are rotating in different speeds or different mechanism. So that's why they require different power, or they provided with a different power mechanism. Their power supply is different in the case of the pan mixers. That's why they are providing different mechanisms. Another here, dual shaft. Here is single shaft. We saw here is the offset axis. Earlier one was we saw that is the central axis. So here in the dual shaft case, another possibility is to have a two shafts rotating in a synchronized manner. Why it is required to synchronize manner? It will not block each other. So that's why the mechanism will be like that only, synchronized manner, or it will rotate according to that one only. So blade is positioned near the inner wall of the pan to scrap the concrete that tends to stagnate near the wall and push it inward toward the rotating blades. Here also the scrapper is rotating and these two blades are also rotating. So that's this type of pan mixer is called as dual shaft type of pan mixer. If the pan is rotating, the scraper can be fixed near the pan wall and remain stationary. And if the pan is fixed, the scraper should be rotate for the pushing the material towards the center of the pan or towards the blade. So usually the blades, pan and scraper are independently power. That is very important. If it is not independently power, then the mechanism will not work. So that's why it is required to have the independent powers for all the blades, pan and scraper. So this all about the pan mixer. Any doubt, anyone? So we saw drum mixers, batch mixers, pan mixers. Then we in that one drum mixers we saw tilting, non-tilting, reversing drums. So we require to provide the 15-degree inclination in the case of the drum mixers to have the efficient or optimizing the mixing energy and as well as to provide the homogeneous mixing. I hope no one has doubt in this up to this one. The next type of mixer is continuous mixers. So what is continuous? The mixer's name itself suggests some information. So the continuous mixers means the continuous batching will happen in that. How? So materials are continuously fed into the mixer at the same rate, and as the concrete is discharged into the same rate, means the whatever the material ingredients will come into the mixer on the one side and other side, the discharge will happen within the shorter period of time. So usually consists of non-tilting drums with screw type blades rotating inside the drum. Why we are using non-tilting drums here? Because non-tilting drums we required because we are providing the mixing gradients on one side and the discharge on the other side. So the non-tilting drums only provide that arrangement, and tilting will, no doubt, tilting will have certain advantages. But in the case of the continuous mixers, we are going for the continuous batching. So the inch in what we called the inside of providing the insertion of the concrete materials and the discharge of the concrete materials, we require the different arrangement. So drum is tilted downward toward the discharge opening. Little bit downward discharge opening it is tilted towards. And the mixing time depends upon the drum slope, usually about 15 degree. So use for applications requiring short working time. Remember this one. Where it is required, short working time, long unloading time, remote sites or small deliveries. Not suitable for ready mix concrete. Mainly used for low slump concretes, and due to short mixing time, the air content is difficult to control even with air entraining admixtures. So, can anyone tell me what is the or where we can use this type of mixers on in the site? Which type of concreting we can use it? This one. Too many information is given into this slide itself. Based on that one, you can just relate this information whatever the special type of concretes we have learned previous lectures. And can anyone tell me what type of concreting we can do with this type of mixers? Mass concreting or okay, any other? Yeah, mass concreting is also possible. Which one? Can you repeat, please? Lead concreting. Mass concreting is possible. Mm, yeah. No, you see what this one sentence you can see here mainly used for low slump concretes. So right. Because you can see short working time, long unloading time, remote sites and small deliveries. Now, low slump concretes. We saw the roller compacting concretes are almost zero slump concrete, right? So in that case, also we can use, and if the slump is within the range, we can use for the mass concreting also. Okay. So this sentence you can be keep in mind that short working time, long unloading time, remote sites, small deliveries, and low slump concretes. And why short mixing time is creating a problem with the air entrainment or air content? Any idea? What happens in the short mixing time? Why air content is more or it difficult to control? Yeah, water cement ratio will be less because of the we have the low slump concretes. Okay. A short mixing time sometimes there is a will not allowing or control air is not possible because it requires the larger mixing to provide the continuous distribution of the air bubbles with the air entraining admixtures. So in the short mixing time, it is difficult to even with the air entraining admixtures, it's difficult to control the air content. So that's why non-homogeneous we will observe the air entrainment or bubbles formation. Okay. So further we'll see mixing concrete. So concrete should be mixed thoroughly until it appears uniform with all ingredients evenly distributed. Means evenly distributed means there should be a properly slump formation or whatever the slump we require that should be achieved. Then another thing is that you should not observe any type of the segregation or any type of the dry mix available inside the concrete mixer. So then only we'll say the mixing will carried out thoroughly and uniformly. So mixers should not be overloaded and must operate at the recommended mixing speed. What it indicates means suppose you have the mixer capacity of 100 kg mix at a single batch, and if you want to provide mix the concrete up to 125 or 130 like that, and you provide all the material into the same mixer which is having the mixing capacity of 100 kg. No doubt, mixer will have a certain amount of more capacity. Mixing capacity is different and occupying capacity is different of the mixer. It can occupy material up to 150 kg, but mixing capacities depend upon the mixing energy, right? So it will be different from the occupying capacity. So material can occupy 150 kg and you have provided 130 kg, but mixing capacity is 100 kg. So in that case, what happens? The material will not provide homogeneous mix or mixer will not provide homogeneous mix. It will create certain amount of extra bubbles in that one or certain will not provide the distribution of the water surround all over the concrete mix. So whichever we require the fresh properties such as slump and the flow that will not get properly and we'll see the material is not properly designed. But material is properly designed, but you are not using the proper mixing equipment. So that's why you'll not get the proper properties. So not only mixing design is important, the execution is also important, or mixing is also important. So that's why mixers are also very important in the case of the concreting. So increased output should be achieved by using larger or additional mixers, not by overloading or speeding up equipment. Again, same if you are using same equipment for the larger for the increasing output, you increase the speed. Increasing the speed, you may be allowing the concrete to get the segregate or providing the bleeding. So you'll not get again properties, and you'll see the mix. You will say that the mixed design is not properly. So you will lose time there also, and you will lose the your material additional cost. You will get it. Then mixer blades are worn or coated with a hardened concrete. Mixing efficiency decreases. Most of the times, even in the labs also, or even in the construction sites also, if the mixers are not properly clean, there is a possibility to the material is adhere to the or stick to the surface of the mixers, and that uh, reduce the efficiency of the mixing by absorbing the moisture from the new mix, or the blades will not allowing the proper homogeneous mixings if the that concrete is too more there or attached to the blades. So that's why properly mixed concrete will have a consistent density, air content, slump, and coarse aggregate content throughout the batch. This is the visual inspection you have to do for the concreting. Then we have some of the fresh properties testing. That one we can do, and then we can see if that is within your requirement. You can say the concrete mixing has been done properly and thoroughly, and you got the homogeneous mix of the concrete. Another type of mixing is stationary mixing. Stationary mixing means concrete is mixed on a site in a stationary mixer or paving mixer. Includes on-site mixers and central mixers in ready-mix concrete plants. It can be done concreting or mixing up to 9 meter cube. Any type of mixer will be available: tilting, non-tilting, or open top rolling blade paddle type. May be equipped with loading skips and swinging discharge chutes. Many mixers have timing devices to ensure the required mixing time before discharge. Timing devices for what purposes? Any idea? Some persons are from industry, might be they have this type of mixers on their site. Can anyone please tell me? Anyone? Timing, yeah, yeah, right. Yeah, homogeneous mixing. Suppose like you are providing any mixing time. Total mixing time is, suppose you have a half an hour or 30 minutes. You total mixing time, and out of that one you are considering 10 minutes for the dry mixing. Hmm? So automatically you'll set the timing into that devices, and dry mixing you will do for the 10 minutes, and automatically after that whatever the water or whatever the aqueous solutions you are providing, that will automatically pour into the your mixer. So it is independent on the workers. It is provided by the machinery equipments, that timing. According to that time, the like suppose you said half of the water added initially, then 2 minutes again homogeneous mixing. After the 2 minutes, again the water will pour remaining water, and then again homogeneous mixing. And after the 30 minutes or 20 minutes, whatever the time required for the homogeneous mixing, after that discharge purposes, the mix will automatically come out of the mixer. So this is the fixing time, or time will fix for all the mixing procedures. That is for that purpose, timing devices are provided into the big plants. Like suppose you can say 9 up to 9 meter cube concreting you have to do. In that case, it is required, or it provides some more efficient way to control mixing procedure and give a more homogeneous mix. How much mixing time actually requires? Obviously, it depends on the type of the mixer and the type of the concrete, or producing the concrete on which type. So mixing time usually 1 minute plus 15 seconds for each cubic meter of concrete is recommended, but it's not as I said, it's subjective case. It is dependent on the too many factors. So you have to find out for your concrete. Short mixing time can cause non-uniform mixes. This obvious poor air distribution, low strength, early stiffening because of the not obtaining proper fresh properties. Mixing time is measured when we have to measure the mixing time. Mixing time is measured after all cement aggregates are in the drum with water added within the first one fourth of the mixing time. Means cement and aggregate you added into the drum, dry mixing you have done, and you added a water, then only mixing time you have started because the hydration only starts after the water addition. So that matters actually for the initial and final setting time purposes. About 10% of some are the recommendations given from this slide. You can see 10% of the mixing water should be placed in the drum before adding solid materials. Then water should then be added uniformly with the solid materials, leaving about 10% of the added after all the materials into the drum. Means suppose you are creating producing one concrete mix, and you provided suppose 10 kg of water. So out of that 10% you added initially to the empty drum, then solid material you are added, and with along with that one you added some amount of water, and then remaining 10% of added. So this is the recommendation. This is also subjective case. Then another case is that when heated water, when we are using heated water in the case of the cold environment or cold weather conditions. So in that case, there is a possibility when the heated water comes in contact with the cement content, there is a heat of hydration fastest and stiffening or rapid hydration will happen. So in that case, you have to be change the charging order. Charging order in the sense the material pouring order. Cement you can pour at the last. At the last, in the sense, you first of all you will put all the dry ingredients except cement or cementitious materials, then water, and then you will mix it. And at the last, you will provide the cement, and then you will mix for some time, and then you will pour or discharge that concrete and place it into the execution wherever you want to execute that concrete process. So in such cases, cementitious materials should be added after most aggregates and water are well mixed within the drum. That only I said just now. So cement you have to or cementitious materials you have to add into in that case at the last of the mixing process to avoid the rapid hydration process. Otherwise, you will have a very limited time for the concreting purposes. Another some points about the stationary mixings. When the mixer is charged directly from batch plant, materials should be added simultaneously. So that charging time is similar for all the materials. So charging time is similar, we required for similar for all the materials. That's for that purpose only we are providing the timing devices, which can automatically control this all the procedures, and we provide the homogeneous mix. That's why timing devices are very important in the case of the stationary mixing or large batching processes. If supplementary cementitious material are added, they should be added after the cement. Then retarding or water reducing admixture should be added in the same sequence in every batch. Same sequence means whatever the order you are keeping for this producing the multiple batch of the concretes by producing the or using the same constituents of the materials. Suppose you are adding the water reducing admixtures with the water by adding with the water, and then you are adding. So in every batch of the concreting, you have to follow the same procedure or same protocol. Then only you will be able to get the same fresh and harden properties. Otherwise, you will not get the same properties. So mixing protocol is very important, whether it is regarding to the dry ingredients or whether it is regarding to the liquid ingredients such as the any type of the chemical admixtures. So that's why here also it has mentioned variations in initial setting time and internal air content may occur if you are not following the same procedure for every batch of the mix by producing the same concrete by using the same constituents of the material. Admixture addition is very important if you are using the two or more different types of the admixtures. You cannot add together. Suppose you are using the super plasticizer, that is PCA based super plasticizer, and suppose you are using the viscosity modifying agent, that is HPMC. You cannot add together. Why? If we add it together, they may not work efficiently or they have adverse effect on the concreting, because the purpose of both admixtures are different. Viscosity modifying agents purpose is to create the viscosity or modify the engineering viscosity, and super plasticizers is it is reducing the viscosity, reducing the yield stress, providing the more flowability or workability by removing the trap water from the cementitious flocks. So that's why you have to add admixtures differently, in different order or separately, to avoid interaction affecting concrete properties. So the order of adding admixtures to the mix is also different. It's very important if you are using one or two or more type of admixtures. Further, in the case of the ready mix concrete is proportioned and mixed at central plant and delivered to the site in fresh and unhardened state. But there are different types of ready mix procedures, such as central mix concrete. Central mix concrete means completely mixed in a stationary mixer and delivery in a truck agitator or non-agitating truck. Second is shrink mix concrete, partially mixed in a stationary mixer and completed other mixing procedure into the truck itself. And the truck mix concrete completely mixed in a truck mixer. So can anyone tell me where we can use central mix concreting? Because we are completely mixing into the stationary mixer, and then you are delivering with the truck agitator or non-agitating truck. So, yeah, RMC is there, but if the distance is too much, suppose within the 20 minutes or 10 minutes, you can completely mix in the stationary plant and then you can provide it. But if the distance is more, you can go with the shrink mix concrete or truck mix concrete. Because if you are not here, you see in the first sentence it says truck agitator or non-agitating truck. Non-agitating means truck is not moving. So if you are not moving, the not agitating that material, the material will get set, right? So that's why shorter distance, then you can go with the central mixing. For the longer distance, you cannot go with the central mixing. So it will be highly efficient if you go with the shrink mix concreting or truck mix concrete. Further, we saw mixing energy. So what is the exactly mixing energy? Mixing energy is the product of mixer power and mixing time. So we are providing the power with the electric power, and mixing time depend on the your mixing procedure. If you are providing a 10 minutes mixing time or 20 minutes mixing time, according to that product, you will give it a mixing energy, and it will be differ for different types of the concreting and different types of the mixers. In the case of the pan mixers, where you are providing the different types of powers or independent powers to all the three: mixing blade, pan, and scraper, their mixing energy will be higher as compared to the other type of the mixers. More powerful mixers can mix less workable or higher viscosity concrete. More powerful mixers means more rotating or RPM you are giving. Where if it is a stiff concrete or higher viscosity concrete, you require higher amount of power. I hope you have seen the mixers used for the ultra high performance concrete, which is generally has the higher RPM compared to the normal concreting. Why? Because ultra high performance concrete is highly viscous concrete or workable. You can less workable, you cannot say, but higher viscosity. Viscosity is compared to the normal concreting, it's very high in the case of the UHPC, and there you are using fibers also. Then you require the higher amount of RPM or higher mixing energy. So that's why more powerful mixers are used in that case. Similar mixing energy can be achieved by using the less powerful mixer and more workable concrete by changing the power and mixing time. Another some recommendation in the case of the lightweight aggregates. Lightweight aggregates, which one? Porous aggregates. If you are you design the concrete by considering the absorption of the water of the aggregates, then you can go for the this porous aggregate case. Higher absorption is done. That water, one half the two third of the total mixing water should be pre-mixed 1.5 to 3 minutes. So first of all, you put the water, then aggregate that lightweight aggregates, and you will mix it with that water for 1.5 to 3 minutes. Why we have to do that one? If you directly put the cement after the aggregates, the cement will go into that pores, and that cement amount will get reduced for the hydration purposes. So it should not be done. For that purpose, we'll go for the initial weight mixing for the lightweight aggregates. Sometimes you can go for the saturated surface dry condition aggregates if you don't want to absorb extra water by this type of porous aggregates. For that purpose, what you will do, whatever the aggregates you are using, that you can pour into the concreting, not pour into the water for 24 hours. Then you will remove that aggregates, will place onto the within, not exactly onto the sun, but into the some shelter, and you will see whenever the running water is not available into that aggregates, you will use as the saturated surface dry condition aggregates, which will not absorb any extra water from your concrete. Heavy aggregates means normal aggregates you are using. That is good practice to dry mix aggregates with cement for about 1 minute before adding water, and then after adding water to get the uniform mixing or homogeneous mixing. So it is also very important wherever while mixing you have to consider our material or constituents of the any material will not go anywhere. That's why you will get if you are carrying that, then only you will get the same properties for the same batch of the mix. So you have to keep in mind this all the aspects of the pre-mixing also. So the recommended order of adding materials, that initial dry mixing stage followed by wet mixing stage, certain amount of water you can add it for the wet mixing stage. Then coarse and fine aggregates are first checked for moisture, weigh and place in the mixer. If required, air entraining admixture is added along with the aggregates. Cementitious materials are then added, dry mix to obtain uniform blend up to 30 seconds. Finally, remaining water and other admixtures are added and the mixer is mixed again. So further we are mixing again for to get the all the homogeneous mix. So the further adding or further mixing time will be the constant for each batch. So then only you'll get the same homogeneity for each batch. So what are the key points we have to be remember in the case of the batching of the concrete and mixing of the concrete? Water reducing admixtures are added after cement wetting. Now we have some are added at that time of point of time after waiting, and some can add after before that one also. So what it indicates, early addition improves slump retention and dispersion, but requires higher dosages. Later addition reduces slump retention but needs lower dosages. So according to the requirement of your concrete, if you require the slump retention for the means slump retention means suppose you are producing the concrete of the 100 slump and you want to maintain that 100 slump for half an hour, then you can go for the early addition, which will disperse all the flocculated cement particles and remove that trap water inside that one. But in that case, you require the higher dosage of the water reducing admixtures. And if you don't want to maintain the slump for the long time, then you can go for the latter addition. After all mixing has been done, you can add the this water reducing admixtures, and it requires a lower dosage as compared to the earlier one. Liquid pigments are added at the beginning of the final mixing cycle with other admixtures. Final wet mixing time depends on the mixer efficiency, that is RPM of the mixer and the type of the mixer, which gives the which decides the efficiency of the mixer. Improper sequencing of admixtures may reduce effectiveness or cause premature or late action affecting concrete performance. Improper sequencing means Wherever you are adding type of the admixtures such as superplasticizers or viscosity modifying agents, and if you are adding together, that has a different effect on the concreting. So that is called as improper sequencing. So sequencing you have to be keep in mind, it should be the same for all the batches. Then air entraining admixtures should be introduced separately onto aggregates or in mixed water to avoid interaction with other admixtures. So this all about the mixing procedure and the types of the mixers. So anyone has any doubt till now? If no, then we can move forward with the next one, that is shotcrete. We already saw some brief introduction about the shotcrete in earlier lectures. So now we'll see some of the main aspects of the shotcrete. What is shotcrete? A concrete delivered to the final point of placing with the help of the pipe, which is sealed, pressure resistant, and applied by spraying. Obviously, if you are spraying the concrete should be different from the normal concrete. What is in what aspect it will be different? It will be more flowable, but at the time of considering the flowability, it should not be segregated. It should not be occur. It should not be providing any type of bleeding. So that aspects you have to be considered, and you have it has to be flow through the pipes. Means it will have a certain restrictions on the maximum size of the coarse aggregate, right? So we'll see what is the maximum size of the coarse aggregate and what are the points we have to keep in mind while developing the shotcrete concreting. So these are the some of the applications of the shotcrete concreting where it has been used. You see, some mesh has been provided on the some sloping portion, and you are doing the concreting layer. This persons has been lifted some distance up with the help of the crane, and then they are doing the concreting with the help of this nozzle. You see, the pressurized concreting has been done over this one, and it may be the first layer. After that, maybe they are providing the second layer also. Another application is that lining of the tunnels. The curvature portion of the tunnel will be do lining with the help of the concreting. Here also they are providing some type of the meshing. Then with the help of the shotcreting, you will provide the this is the first layer and this is the second layer they are providing over that one. Here slope stability. In the case of to avoid the landslides, in that case what they will do, they will provide here also some meshing and they will do concreting over that one with the help of the shotcrete. So it will provide some type of the slope stability for the sloping portions. These slides we have already seen in previous lectures. Can anyone tell me what he is doing and what is this one? Or what is the purpose of doing this? We already seen this image in previous lectures. Yeah, mock also you can say. And another thing is that if you want to do or if you want to find out the compressive strength of the that concreting shortcrete concreting, you can provide the whatever the slope you are on whatever the slope you are actually doing on the site, that slope you can provide here and you can do shortcreting from that distance only, because distance also matters from where you are providing that spray of the concrete. And similar curing conditions you can provide here, and you can get the course from here and you can do for the concrete testing, that is compressive testing for that purpose. And to obtain the or to get the optimum distance for the spraying, optimum slope, that things you can get through this mock concreting or mock things here doing. So what are the applications of shotcrete? It can be used for the bridges and dams. For what purposes? For the rehabilitation. So suppose any bridge has some part of the construction has been required to be rehabilitated, that purposes you can do for the shotcrete concreting within the short period of time. You can do it. Sewer lines such as sanitary, storm culverts, basins, head walls, wing walls, then piers and docks, beaches, retaining walls, slope stabilization. So plenty of applications are available with the help of the shotcrete concreting. So properties of the shotcrete as place depend not only on the material proportions but also on the skill of the nozzle man. In other words, workmanship is of critical importance in quality control plan. Nozzle man means the person who is spraying the concrete over the surface. That person is called as nozzle man. So what are the skills required? How much distance he has to maintain, and uh, what we called how we have to place or spray that concrete over the surface, in which direction, vertically or in the horizontally, according to the protocol. That he has to be keep in mind. So that's why nozzle man also plays a very important role to get the proper shortcut concreting. So in some of the countries they have course for or some specifications for the nozzle mans also. So shortcreting can do two ways. One is a dry mixing process, another one is the wet mixing process. So, what dry mix indicates? It indicates a pre-mixed blend of dry constituents of the mix, and then the water will add exactly before spraying the concrete. What means you see this flow chart: cement plus moist sand plus coarse aggregate is optional, or it may be the restricted size of the coarse aggregates. First of all, it has been added, then it is put into the delivery equipment with the help of the distributor or feed vessel. It come into the delivery hose, means the pipe, and with the help of the compressed air, that material is flow. That dry material is provided or flow through towards the nozzle, and towards the nozzle, the water under pressure has been added. So once you are adding water here, there should be a proper mixing carried out in this dry material with the water. Then only it can spread here. So there may be some mixing uh, or mix what we call the extruder will be available here, which can mix it and then you can spray it here. So this is called the dry mix. Means we are adding water into the latter stage of the shotcreting. In the case of the wet mixing process, obviously all the materials in our ingredients were mixed together with the water. Then it went into the delivery equipment. Then with the help of the distributor and feed wheel, it come into the delivery hose. And with the help of the compressed air, it will come into the nozzle. And in the nozzle, now you are providing the accelerator. The dosage you have to be maintained according to the flow you require. That is also the skill required by the nozzle manship. So then only the material will spray onto the slope or slopy surface, and it will, because of the accelerated, it will be hardened, or rapid hardening will happen. So given the method of placing, shortcut ingredients are also at times pre-bag, though the ingredients can be batch and mixed in the usual manner as well. Means the shortcut material will be pre-bag also. Pre-bag means some of the construction companies now coming into picture which provide the shortcutting mix into the bagging. Just you can go to the site, whatever the mixer you will have, put into that one, and directly you can get it. So pre-bag mix is already tested for the what are the compressive strength of that one, and what are the water requirements required to get the homogeneous mix. But it will be additional cost if you are going for the pre-bag mix. Then, given the nature of construction, fiber reinforcement shortcut is an excellent option, because already we are providing meshing only. Then you are putting the shortcut layer, and the shortcut layer will have some amount of thickness, but there is a possibility will not get the proper strength, that is ductile strength of that one, or tensile strength of that one. So in that case, now fibers are added. For what is the purpose of the fibers? We saw fiber reinforced concrete in the last lecture. What is the purpose of fiber in the case of the shortcutting? You will see into apart from the tensile, right? To control the formation of the cracks. Because what happens? One thing you have to keep in mind: we are restricting the size of the coarse aggregates, right? Once you are restricting the size of the coarse aggregates, automatically cementitious content will be the higher. Cementitious content will be higher. Another aspect is that you will not directly using the same curing conditions as you are using for the normal concreting. Here, curing conditions are different. So there is some chance where we can observe the cracks also. So to avoid that one, or to restrict the crack widening or crack occurring, fiber reinforced shotcrete has been carried out. So, what are the other materials? No special material in such except care has been taken in the choosing cement coarse aggregate, shape and size, chemical admixtures according to the requirement on compatibility and fibers. Quality control is carried out on the basis of compressive, tensile, and flexural strength or any other relevant parameter depending upon the specific applications. Specific applications means suppose you are doing shortcutting for the sewer lines, there and then you can doing shortcutting for the tunnel lining. The requirement will be different, right? So according to that one, you have to carry out the quality control process and the you have to keep in mind the compressive, tensile, or flexural strength properties that you can do into the mock process. So what are the main characteristics of shotcrete? Low water to cement ratio, especially for the dry process. High early strength, use of accelerators. High early strength requires to get harder early. That's why you are using accelerators also. Rebound of material after placement means you spray the material over the surface, slopy surface or lining surface. Then that material should not get rebound or should not, because of the force, that material should not get back it. That is called rebound. So that should be stick to the surface. That rebound of the material should be less. Compaction due to application with the high speeds. The compaction should be proper with the speed. So that speed you have to find out or optimize for your mix. Reduce cost on account of savings from formwork. As we are not using any type of formworks, the cost related to the formwork has been reduced. Very important aspect of the shotcrete concrete. Ideally suited for the thin layers, cannot be placed in thick layers in a single pass. If you are doing single double layers, then you can get the proper thickness, double thickness also. But usually you'll do for the thin layers which can provide the sufficient amount of the cover for the mesh, which cannot go or which cannot provide which cannot give any additional or adversary effects for the corrosion for the steel mesh. So, can anyone tell me why low water cement ratio is in the dry process and higher water cement ratio is required for the wet processing? We saw two processes, right? Dry mix, yeah. It depend on the along with that water you can use it, but additionally you can have some more time than for the mixing into that before the spraying itself, because at the same time if you're using the water or adding the water and the accelerator also, or otherwise you can use the accelerator which you can directly mix with the water. That type of accelerator you can use it. So the you can use it in the dry mixing process also, in the wet mixing process also. That's not an like you cannot use, but additional input you have to give it, and mixing you have to be more, because after adding the water, then for the accelerating you have to be little bit more mixing time required. But why we are using the low water cement ratio in the dry process? Any idea? Which No, but that is also, that sticky mix requirement is also into the wet mixing process. Both, even in the shortcrete we require the stickiness. That doesn't depend on the like dry and wet mixing. The thing is that for the dry mixing and the wet mixing, if you see, we saw self compacting concrete. Flowable material, if you want to flow, we required minimum amount of viscosity, and if we have the minimum amount of viscosity, the pumping pressure will be the less, right? So if water cement ratio is higher, the viscosity will be less in the case of the wet mixing process. So that's why wet mixing process has higher water cement ratio compared to the dry mixing process, because it has to be flow through the pipe with the help of the liquid constituents. But in the dry mixing process, you just providing the compressed air, and with the help of that force only, the material will come into the near the nozzle, and that's why more requirement of the accelerator is in case of the wet mixing process, where you are already providing the higher water. So higher water means higher workable material, higher flow. So to get hardened fastly, there we are adding the accelerator. But in the dry mixing process, if required, you can add it. Okay, understood. Why high water is required in the case of wet mixing process? Curing. So curing, it will not be the same exactly like normal concreting. We have to go for the some additional procedures for the curing. So we can maintain the moist conditions wherever we do for the shotcrete concreting, continuous sprinkling of water, covering with wet mats or wet sand, covering with impervious sheets, using curing compounds. The curing compounds you can spray over the shotcrete surface. If relative humidity is higher than 95%, external curing requirements may be reduced. So humidity plays a very important role. If it is humidity is high, the external curing requirements may be reduced, because already humid has some amount of the moistures in that one. So that will provide this additional curing. But it is very important to have the proper curing of the shortcreting, because we don't provide the normal curing procedures for that one. So that's why special care has to be taken in this case. Fiber reinforced concrete, shotcrete. What are the types of fibers we can use? Steel, synthetic fibers, but it should be uniformly dispersed in shotcrete. It improve ductility, cost competitive, offer better safety and easier application compared to the traditional reinforcements. We saw this one, that in that mock test also, like this mock test, you will spray the uh, shotcrete over the surface from the certain distance, that is optimized distance, and number of layers you will decide, angle here you will decide, and curing time you will decide. After the curing, or in curing conditions also, after that one you will extract the cores from the panel, and you will do the testing, the cores for that testing, and you will find out the compressive strength. You'll do for the flexural strength also. For that purpose you can get the specimen according to that one, and tensile strength also you can go find out with the help of that one. You can go for the splitting tensile strength test in the case of the cylindrical core. So these are some examples where we have done this one, rehabilitation of corrugated steel pipes. This is, you can see steel pipe sewer line is there, and it has been corroded properly. So now you can see the steel meshing has been provided and short kitting has been done. After rehabilitation, you can see this type of the sewer. Now, no doubt we are compromising the diameter of the sewer, but we are reducing the cost of complete replacement. So that is beneficial or economical according to that cost perspective. If you see that one, another that one sewer line, that is brick sewer line, it has been done by shortcutting, improve or enhances its life further. Then you can see bridge here, some concreting has been spell out. So in that case, You can do with the help of the shortcutting, rehabilitation of the infrastructure bridges also. So this is the brief overview of the shortcut concreting. What we have to remember here, two types of mixing process. Why water content is higher in the case of the wet mixing process. Then nozzle workmanship is also important aspects apart from the material constituents. How we can do mock testing, and then only we can test the compressive strength specimen, flexural strength and flexural strength specimens, and what are the applications of that one. Maximum size of the coarse aggregate, you have to restrict fibers we can use to restrict the cracks and give the additional ductility to the shotcreting. Okay. The next point of this discussion is that high strength concrete. So according to the Indian Standard Code, there is an three types of concrete has been mentioned: ordinary M10 to M35, standard M40 to M75, and high strength it is M80 to M100. But there is no universal definition for high strength concreting. So why it says that? Because high strength, you cannot use the equations used for to find out the modulus elasticity equations used for the normal concreting. You cannot directly use for the high strength concreting. For that purpose, you have to test the number of samples. You have to find out the your characteristic strength equation, your modulus of elasticity equation for your high strength concreting. So its characteristic strength is defined based on the test of cubes or cylinders, so grades cannot be directly compared only by numerical values. Means you have to do for your high strength concreting. Normal strength concreting cannot directly use it. What is the most important aspect of the high strength concrete is interfacial transition zone. I hope you remember we saw what is interfacial transition zone and why it is important. Because what happens when we are adding coarse aggregates into the concrete, there will be a water will flow towards the surrounding of the coarse aggregates, and lighter cement particles will also come nearby that one. So in that case, you will observe there is a high water to cement ratio nearby the surrounding the coarse aggregate. You will observe the higher CH content, lower CSH content, because of the lower cement particles, whichever the lighter, that only come into that zone. And because of that one, you'll observe more porosity nearby the or surrounding the coarse aggregate. That is called the interfacial transition zone, and that is the weakest part of the concreting. Right? We saw this all the aspects in the previous lectures. So can anyone tell me? We saw also what is the approximate thickness of the interfacial transition zone. We already seen this one. What is the approximate thickness of the interfacial transition zone? No one remembers. It will be 50 micrometer. How much? 50 micrometer. So you can remember this thing. It is approximate one. It may vary, but it is approximately recommended that 50 micrometer is the interfacial transition zone width or thickness. So since the transition zone and mortar phase in high strength concrete are quite strong, in high strength concrete, what happens? We are using the less water to cement ratio compared to the normal concrete. How much it is in the normal concreting? How much we are using? What will be the general water cement ratio into the normal concreting? 0.4 to 0.5, 0.45, right? Yeah. So in the high strength concreting, so what will be right? Yeah, point means below zero point 0.3 according to the strength you required, right? You goes below zero point 0.3, strength will get increase, right? And why it is getting increased, we already seen in the previous lectures. So in that case, what happens? Already you have a less amount of water, means there is a possibility you have a less workability also. So that less workability you can compensate with the help of the super plasticizers. But as you are having the less water content, which is has the less direct relation with the strength, compressive strength. So automatically compressive strength of the mortar phase also increases, and at the same time less amount of water available. Because of that one, interfacial transition zone strength is also important. So in the case of high strength concrete compared to the normal concrete, complete different failure pattern you will observe because of the higher strength of the that is weakest zone. What is weakest zone? That is interfacial transition zone, and highest compressive strength of the mortar phase. So in that case, it is very important to use or select the coarse aggregates properly. So what we have to keep in mind: strength of the coarse aggregates. What is strength of the concrete coarse aggregate means? Crushing strength. We saw into the according to the IS 456 in our bachelor's how we can calculate the crushing strength of the coarse aggregates, then grading of the coarse aggregates, and alkali reactivity. These 3 points you have to be keep in mind, or you have to be take care, because strength of the concrete tends to decrease as the maximum size of the aggregate increases. Why? Because as you are increasing the aggregate size, automatically cementitious content goes on decreasing. Cementitious contents goes on decreasing. You are reducing the your calcium silicate hydrate gel formations, and because of that one, non-homogeneous concrete will observe, and because of that one, you will have a less strength in the case of the higher maximum size of or higher size of coarse aggregates compared to the smaller size of coarse aggregates. So in the case of the normal high strength concrete, there is no major difference in raw materials except the coarse aggregate sizes in and water cement ratio. But however, stricter quality control and careful material selection is required. Aggregates are used for high strength concrete should preferably have a high crushing strength, maximum aggregate size limited to 20 mm to reduce the transition zone effect and obtain a more homogeneous concrete. Another, using smaller coarse aggregates increases the requirement of mortar paste content. So higher paste content requires, and already we are increasing the cement content because of the reducing the coarse aggregate sizes. So in absence of larger aggregates, concrete becomes more homogeneous with a smaller difference between the strength of the coarse aggregates and the mortar matrix. So how much cement content? Usually very high, about 400 to 600 kilogram per meter cube. Can anyone tell me what code suggests for the normal concreting highest or maximum amount of cement content? What is the value of the maximum? Right. No, this is 400 to 600. This is for the high strength, and the code suggests for the normal concreting is 450. Okay. So apart from the normal, you will see higher amount of cement content here. So higher cement content results from the because of the limiting the aggregate size and need for the workability at lower water cement ratio. It is giving more homogeneous concrete increase because paste content increases, lubrication increases. So enhancement of workability you can also get with the help of the super plasticizer also. Then water reducing and mineral admixtures such as flash, slag, silica fume are often used in high strength concrete mixes. Can anyone tell me why we are using this type of mineral admixtures in the high strength concrete? It is very common to use in high strength concrete, right? Better pore filling ability because of its latter edge strength gaining effect, right? Because most of the mineral admixtures you will use whatever the byproduct of the hydration process, that is calcium hydroxide, will use for the further hydration processes and will provide additional CSH gel in the latter age of the hydration process. So that will fill the pores and provide the high strength as well as improve the durability aspects of the concreting. Another, right, after 28 days, most probably it's go up to 56 and 90 days also. So that's why it is very necessary to test the specimens up to 90 days, 56, 28, 56, and 90 days in the case of the high strength concrete, where we are commonly using this type of admixtures. You will see into the literature also, most of the researchers will test up to the 90 days. Another, yeah, and another thing why we are using this one, you forget that we are using higher amount of cement content, right? So higher amount of cement contents means higher heat of hydration, right? So higher heat of hydration. So to reduce the heat of hydration, you have to use the this type of cementitious contents, which can give all the paste content, but you are reducing the part because this mineral admixtures you are replacing this one, right? You will replace the cement content, and then you'll that replacement you will use at the mineral admixtures. So mineral admixtures will not provide heat of hydration into the initial phases. So automatically you are reducing the initial hydration, and because of that one, you are reducing the cracking because of the thermal ingredients. Another important aspects in the high strength concrete are very important. That is water to cement ratio. We saw water to cement ratio is less because it has a direct relation with the compressive strength. Lower the water cement ratio or water to binder ratio leads to higher compressive strength. Here into the higher high strength concrete, you will observe zero point 0.3 or lower. Reducing workability can be accompanied with the help of the adding the superplasticizers. Superplasticizers, we saw what it does. Two types of superplasticizers, sulfonate base and polycarboxylate base polymers. So sulfonate base, what will do? Electrostatic repulsion of the cementitious particles and remove the trap water from the flocculated cement particles. In the case of the PC based superplasticizers, they will create the steric endurance between the cementitious particle. Basically, it is the dispersion type of that one, or force is creating to disperse the cementitious particles and remove the trap water and use at a mixing process. But because of the lower water cement ratio and high cement content, there is a high possibility to observe large autogenous shrinkage and high rate of hydration. We saw that because of high cementitious content, high rate of hydration observed. So, what is autogenous shrinkage? Can anyone? What is autogenous shrinkage? Autogenous shrinkage. Uh, hmm, hmm. Volume reduction of cementitious materials, but not due to evaporation of the water. That water has been used by chemical reaction itself. So because of that one, volume reduction happens, and because of the as concrete hardens, the volume reduction will not allow the hardened concrete, and because of that one, cracking will happen, right? So this may lead to cracking. So special attention is needed to control cracking in high strength concrete. Special attention means we have to cure properly, right? So proper curing conditions you have to be provided into the high strength concrete. Cracking can reduce water tightness and durability. Also, the actual strength of the concrete in structures may be affected by factors such as curing conditions and scale of casting. Obviously, whatever the testing, compressive testing, and the other type of testing you are doing into the lab, that will may differ onto the site because of the high strength concrete. We required special care for the curing conditions. So curing conditions may be differ in the lab and into the site. So it is necessary to provide the same curing conditions and the proper curing conditions to get the maximum efficiency of the high strength concrete and provide the better durability aspects. Use of silica fume. Silica fume has been used widely into the high strength concrete because incorporating mineral admixtures such as silica fume, what it is very small particle in size, that is spherical in nature. It fills the gap between the cement particles, creating a denser microstructure. Highly reactive amorphous nature allows it to react with the calcium hydroxide, which is the byproduct of the calcium hydration process of the cement, and create the secondary CSH, which fill the capillary pores and producing porosity. So what are the benefits? Reduces permeability because of the reducing the pores. CO2 penetration reduces, oxygen, chlorides, and moisture penetration reduces, decreases risk of leaching, alkali aggregate reaction, carbonation, corrosion, and sulfate attack. And it improves overall durability of high strength concrete. So high strength. So what are the high strength properties of that one? Basically, first of all, we'll see workability related. So it is fresh one, but we'll see workability. So workability, whenever we have having the less than 20 centimeter slump, we can use the measure slump test. And here sand content similar to the normal content and uses high range water reducing admixtures and commonly used for the factory products. Factory products means wherever you are using the precast specimens. In that case, you can do it this one. In the case where you can have a more quality control over the specimen preparations. In the case of the regime 2, slump greater than 24 centimeters means flow will be more. Measure using slump flow. We saw slump flow test in the case of the self compacting concrete. Here, sand content will be the higher, air entering admixtures will be there, high range water reducing admixtures are also there, mineral admixtures with a low water binder to ratio. Similarly, for high flowability concrete, we have used this type of test. But when the slump is in between 21 to 24 centimeter, a judgment should be made based on the concrete properties. Means on the site, you have to see the concrete requirement of your concreting and what are the requirement according to that one. If slump is coming into between the 21 to 24 centimeter, then you have to decide which type of test will be suitable for your mix, whether you can go for the slump and you can go for the slump flow, or you can go for both and you can keep the record of both the test. Air entrainment reduces concrete strength because pores you are creating additionally in that one. But wherever it requires in the case of cyclic freezing and thawing conditions. But the condition is that if you are not using freeze thaw resistance, air content is recommended 2%, and we are going for the freeze and thaw resistance conditions, that is minimum 3%, and maximum is 4% has been given in some of the codes. But that is in the case of the normal concrete. In the case of the high concrete, you can find out or you can search it on Google also what is the maximum condition for the air entrainment. Strength development under applied compressive load. So you can see normal strength of the concrete. This graph you can see the strength development in the case of normal concreting and strength development in the case of high strength concreting. The strength development is higher compared to the normal concreting, or much faster. You can say much faster than the normal strength concreting. Why it is happening? Why you will observe higher or faster compressive strength development in the case of the higher strength concreting? Because what happens as you are having the higher cementitious content, the cementitious content is higher, higher rate of hydration, and because of that one, the conditions will make more faster chemical reactions will happen and will create almost what we can say. You see, in the early age, here in up to 30 days, it shows even in the 5 to 7 days, you will see 58 to 67% strength. In the case of the here, you can say 70, almost 75% strength you are observed in the within the 5 to 7 days only. That's why the microstructure and the stress strain behavior and failure modes under compression of high strength concrete is totally different from the normal strength concrete. So how differs microstructure? You'll see these two images of the microstructure. This is the high strength concrete where the maximum size of coarse aggregate is limited, and you see more homogeneous concrete as compared to the normal strength concrete. More homogeneous means you'll see some types of the pores are available here, but here the porosity is less as compared to the normal concreting, and transition zone effect is also reduced and may sometimes almost eliminated. Means sometimes almost eliminated means the whatever the interfacial transition zone strength has, the similar strength has by the matrix, concrete matrix itself. This concrete matrix and the surrounding the concrete which is having the coarse aggregate, both are having the same strength in the case of the high strength concrete. So that's why the failure pattern gets changes. So how it changes, we'll see within the short period of time. So number of micro cracks in HSC under short term and sustained loading is significantly less than the normal strength concrete. Means within the short period of loading also what happens, there is a certain amount of micro cracks will happen into the normal strength concrete because this weakened part of the interfacial transition zone will give that initiation of the cracks. But in the case of the high strength concrete, there is a less possibility to observe this type of micro cracks, or will observe less number of micro cracks. So failure modes you can see here, two types of concreting. This is high strength concreting and this is the normal strength concreting. So in both the cases, you provided some type of the notch. Why we have provided the notch? To initiate the crack from there itself. If you are not providing the notch, the crack will happen in any area, right? But if you want to see the crack nearby the aggregates, so that's why we provided here notch, and we allowing that notch to initiate the crack from there itself only. Then we go for the sustained compressive loading. You see normal strength concreting. This is tortuous path has been carried by this cracking. This cracking appears surrounding the coarse aggregate, that is into the interfacial transition zone, that is having the weakest part of the concrete. But in the case of the high strength concrete, where interfacial transition zone and concrete matrix which are having the almost similar strength, in that case what happens, the strength will reach its peak and the cracking will appear through the aggregate. That's why the recommendation is that to use the higher crushing strength coarse aggregates to get the higher strength of the more higher strength of the concrete. And this type of phenomena or aspects more important into the fracture mechanics. That's why high strength behavior studies you will observe more into the fracture mechanics part of the concreting. Obviously, the here you can see in the normal strength concreting the cracking path is more longer. Here cracking path is shorter. Here cracking path is very shorter and very faster. Here cracking path is longer and slower. Why? Here it is faster. That's why, because the concrete, higher the strength, higher the brittleness of the material. So more brittle than the normal concrete. Higher strength concrete is more brittle because it's suddenly break it or suddenly crack it. So these aspects you have to keep in mind. More importantly, the fracture behavior, how the crack is appearing, and how you can. We saw. I have asked you question in earlier lecture is that how you can identify the compressive tested specimen by seeing its fracture surface, whether it is a normal concreting or it is a hardened concreting. So you can observe the crack path. If the crack path is surrounding the coarse aggregate, that is normal strength concreting, and if it is crack path is within the coarse aggregate, that is the high strength concreting. So construction of high strength concrete, the effectiveness of needle vibrator in HSC is lower than normal concrete. So abrasion spacing and duration must be carefully controlled. Bleeding is generally less in HSC because less workable concrete is this one. The surface should be protected from drying. Finishing and trowel may be sometimes more difficult because of the less workability. Pumpability should be checked properly before construction. Determining strength in a HSC for quality control. Where mineral admixtures are used with Portland cement, early strength development may be slower. If you are replacing higher amount of cement with the mineral admixtures, the earliest strength will be less And in that case, you have to go for the 56 to 91 days instead of the usual 28 days compressive strength specimens. Comparing cube strength with actual structural strength is more difficult in HSC than normal concrete because of the differs into the curing conditions onto the site. Measure strength is often influenced by the stiffness of the testing machine and testing conditions. So, stiffness of the machine also has a more important influencing parameter in the case of the high strength concreting. So, high strength concreting require the higher capacity equipments. Failure during testing can be explosive, so proper safety precautions must be taken. Why explosive? Because sudden failure, that is brittle failure, happen in the case of the high strength concreting. Durability aspects, aggregate should be checked for reactivity, that is alkali reactivity. So alkali silica reaction should not be happen because high cement content has the high alkali content. Due to dense pore structure, carbonation is generally not a major problem. No pores availability. Although chloride ingress may be limited because of the less amount of pores, cracking must be carefully controlled to ensure water tightness and durability, especially against the freeze thaw conditions. And fire resistance can be concerned because of the movement of the trap moisture in HSC difficult. Means whatever the moisture available into the concrete matrix, that will be easy, that will not be easy to remove from that trap flocculated specimen in the case of the high strength concrete. Because if fire happens, what happens? Because of the increasing the heat, the trap moisture will be used and the minimum effect of the fire happen on the concreting in the normal concreting. But in the case of high strength concreting, the fire resistance can be a concern because of the trap moisture. It's very difficult to remove from the flocculated specimens. Designing of high strength concrete, empirical equations used to estimate the properties such as modulus of elasticity, tensile strength, bond strength, and shear strength are often not valid for high strength concrete. So that's why that all the equations you have to develop based on the testing of your concrete. Lower ductility of HSC, as we saw, brittle nature. So that we have to be considered into the designing process also, because ductility also be required into the seismic zone areas. So this is a very brief overview of the week 7 lectures. I hope you don't have any doubt, or if you have, please let me know. Otherwise, we'll move forward with the questions. Anyone has any doubt? Okay, we move with the questions then. The first question is, in the context of reversing drum mixers, consider the following statements. Statement 1, the drum rotates in one direction for mixing and in the opposite direction for discharging the mixed concrete. Step 2, the same opening is used to add the constituents and add to discharge concrete. So what will be the answer? Okay, both are true. Okay, next question. Consider the following factors in the context of mixing concrete. First, short working time, long unloading time, ready mix concrete, remote sites. So which of the following correctly identified factors suitable for using continuous mixers? We saw some of the examples also for the continuous mixers. Now you can tell me what will be the answer for this one. Second, okay. Any other? No, you can. Okay, only first and two. You are saying this first and first option. Options you can tell me. Option three. One, two, three. Okay. Any other? Yeah. Correct option is four, because we are not using into the ready mix concrete plant. Continuous mixers we are not using, because already we are providing the short working time, long unloading time, and the one more important aspect we saw. we are using for the low slump concretes. So that's why we are not using into the ready mix concrete plants. So option 4 is correct. 1, 2, and 4. Okay. So next is, in a project, the coarse aggregate used is lightweight and porous. As per specifications, the concrete needs to have a provision of premixing. So in this context, consider the following statement. First, cement should be added after the coarse aggregate has been premixed with the water to ensure that cement particles do not become lodged into concrete pores. Second, premixing the coarse aggregate with the water facilitated saturation of pores with water. What will be the answer? Okay. Any other? Right. Both the statements are true because both the statements are saying same thing in other directions. Why we are using, right? So next question is, consider the following parameters in the context of shotcrete. First, use of retarders to prevent cold joints. Second, low water cement ratio. Third, high release strain for compaction due to application with high speeds. So which of the following does not apply to construction using shotcrete? 2 and 4. Second option. Which of the four? Option 4. Okay. Yeah, option 4 is correct because we are not using retarder, we are using accelerator because we are not going into the layer by layer. First of all, we'll completely uh, complete one layer. If required, then only we go for the second layer. And because of the acceleration, there will not problem of the cold joints. Retarders will not allow to set very fast. So we require earlier strength also. We require higher hydration also. Then use of retarders is the wrong option in this one. So we are not using that one in the case of the shortcutting. So that's why answer 4. Next, in the context of wet mix process of shortcutting, consider the following statements. Statement 1, premix blend of dry cement and aggregate is propelled through a hose. Statement 2, water is added to the mixture at the nozzle and the mixed ingredients are projected onto the application surface. So what will be the correct answer in the case of wet mixing process? Okay, someone is saying 2 and someone is saying 4, right? Any other? 3. Okay. In the wet mixing process, we are adding water in the initial phase itself. We are not adding water mixture at the nozzle surface or nozzle level. That is a dry mixing process. So statement 2 is automatically wrong. Hmm? Here and statement 1 is what is saying premix blend of dry cement and aggregate is propelled through a hose. That is also wrong. We are not propelling through the hose that dry mix and cement and that all things. We are already mixing together with the water in the initial phase itself. So both the statements are wrong. Okay, understood? Next, in the context of shotcreting, consider the following statements. Statement 1, properties of the shotcrete as placed depends on the skill of the nozzleman. Second, very little formwork is required and hence the overall cost is reduced. Both are true. Okay. 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 Yeah. So here the first one is right answer. The first one is true. The second statement one is somewhat tricky, you can say. Because what happens when we are using the we are avoiding the formwork, we are not using the formwork or little formwork is required, automatically the cost of the formwork is get reduced, but we cannot say overall cost is reduced. Why? The sometimes rebounding will increase the wastage of the material. Because of the using the accelerators, the cost is also increasing. So these two types of the cost affects the overall cost of the produce. So reduce overall cost of the production. So that may be subjective case, depend on the requirement or use of your resources or rebound of your concreting. So that's why overall cost is reduced may not be the correct answer. If it is considered that the form of cost is reduced, that is the correct answer. So that's why statement 1 is correct and statement 2 is false. Okay, someone has said this answer, right? So understood why statement 2 is not correct. Any doubt in that one? Okay, we'll move forward then. In the context of high strength concrete, statement 1, aggregate used in making high strength concrete should preferably have high crushing strength. Statement 2, strength of the concrete tends to reduce the maximum size of aggregate increases. So what will be the correct answer? First true and statement false. Okay. Any other? Hmm. Right. Both are true because you can we saw both the statements in the information itself in the slide. Aggregate used in making high strength concrete should be preferably have high strength, high crushing strength because the in the high strength concrete the aggregate itself broken or the path will carried through the aggregates. In the case of statement 2, strength of the concrete tends to reduce as the maximum size of aggregate increases. True, because maximum size of aggregate increases, more non-homogeneity increases, as well as the more weakest part or more interfacial transition zones available. So that's why it is correct sentence. So statement both the statements are true. Next, in the context of high strength concrete, statement 1, high strength concrete is suitable for fire resistant structures. Statement 2, high strength concrete has low autogeneous shrinkage because of low water to cement ratio. Second option. Yeah, right. Correct answer is both are false because you see the high strength concrete is not suitable because the trap water is not easy to get into out in the case of the high strength concrete. In that's why first statement is false. Second statement is high strength concrete has low autogeneous shrinkage. No, it has high autogeneous shrinkage because of the low water cement ratio. It has high autogeneous shrinkage. So statement both the statements are false. Next, high strength concrete has more toughness compared to the normal concrete. Two, high strength concrete may attract provisions of mass concrete even though the member sizes may relatively be smaller. Very nice questions. You have to use some of the knowledge of the previous lectures also. Take your time and think and give answer then. Mm, okay. Yeah. Any other? So you are saying first one is false and second one is true. Okay. Third option. Okay. Any other? Just use it the knowledge of the previous lectures and think it how this we can relate with this high strength concrete. Very important and very nice question it seems. Okay. Yeah, same third option, right? Yeah. Yeah. So the option is correct. Third one is the correct option. Why? What happens? Toughness means the sense the area under the load deflection curve, right? We saw into the last lecture fiber reinforced concrete. So as the brittleness is there, ductility is less. So post peak curve you will not observe. Automatically area under the curve will get reduced, right? Brittleness means concrete will fall before showing the post peak curve. Sudden fall will happen. It will go peak and the sudden straight line will come into picture. It will not show any strain hardening or strain softening behavior. But that's why statement 1 is false. Statement 2, high strength concrete may attract provisions of mass concrete even though the member sizes may be relatively small. Now you see here, we saw mass concreting. Mass concreting wherever the width of the specimen or the dimensions of the specimen will be higher. That's why the core temperature and the surface temperature will be differ, and that's why it's creating the temperature gradient. And the change in the temperature gradient, you'll observe the temperature cracks. In the case of the high strength concrete, what happens? Although you are having the smaller size of the specimens, because of the higher cement content, there is a higher heat of hydration. So that's why the provisions for mass concrete. What are the provisions? To take care of the curing conditions. So according to that one, you have to follow the provisions of the mass concreting to the high strength concrete because of the higher cementitious hydration, higher temperature. That's why thermal gradients you will also observe within the smaller specimens also, which is prepared by the high strength concrete. So that's why both the statements, first statement is wrong and statement 2 is true. So option 3 is correct. Next, in the context of high strength concrete, statement 1, the crack propagation in such concrete may occur through the coarse aggregates. Statement 2, bleeding in high strength concrete is more than normal strength concrete. So what will be the answer? Okay, first one is true, second one is false. Yeah, right. Because bleeding, no chance of bleeding because we are using the low water to cement ratio, right? So statement 2 is false. Statement 1 is crack propagation. We saw brittle nature through the coarse aggregate. That's why high crushing strength required. So these are the important points you have to keep in mind while considering the high strength concrete. So option 2, statement 1 is true and statement 2 is false. So these are the some of the questions where you will get some idea about that this week 7 lectures and week 7 brief overview we also saw. So if anyone has any doubt, we will see. Please let me know. Anyone has any doubt? Have you submitted the assignment 4? Yeah, what is the last date for that? Yeah, okay, okay. So I think they have some criteria that they will not consider all the assignments. They will consider the top something like that. Na? You can see the for the what we call that final marks consideration. Na? So out of eight, they will six they will consider it seems. So hmm, hmm. Yeah, they have made it seems. Na? So you have to what? Okay, 11th. So you can submit it that up to 11th. Yeah. Yeah, additional because that has yeah that will be considered because that problem has happened in between fourth and fifth assignment interchange has happened na? So that's why we requested them to give another assignment so which will be the fair to like assessment process. Okay. So I hope you enjoyed the session and if you don't have any doubt we'll close the session and the next session will be our last session. So we'll meet on next Saturday then. Yeah. Okay. Thank you and bye bye. Good night. Yeah. Good night.